Laws of chemical combinations. Antoine Laurent Lavoisier, 1743 to 94, a famous French scientist, discovered the law of conservation of mass in about 1785 by conducting a series of experiments to clarify the mechanism of combustion. Combustion can be defined as burning of a substance in air. He proved that in combustion reactions, it is oxygen present in the air that combines with the combustible materials. The law of conservation of mass or matter in a chemical reaction can be stated as the total mass of chemicals present before a chemical reaction remains unaltered after the chemical reaction. Let us prove it mathematically. If in a reaction, reactant A combines with reactant B to form products C and D, we express it mathematically as, that is, total mass on left-hand side, that is the reactants, is equal to total mass on right-hand side, that is the products. In other words, we can say that in a chemical reaction, matter is neither created nor destroyed. Let me now check your understanding on the concept by taking a test. Out of the following equations given, locate which one of them follows the law of conservation of mass. Let us take the first example. The first one does not follow the law of conservation of mass, as there is one copper atom on the right and left side of the equation, but there is one molecule of oxygen on the left-hand side and one atom of oxygen on the right-hand side. In the second equation, masses are balanced on the left and right-hand side, so it follows the law of conservation of mass. In the third equation too, masses are balanced on the left and right side of the equation. So, this example too follows the law of conservation of mass. In the fourth equation, masses are not balanced on the left and right side of the equation. So, it does not follow the law of conservation of mass. In the last equation, we find that masses are balanced in the right and left side of the equation. So, it follows the law of conservation of mass. Let us take two sets of chemicals, X and Y. Set X contains 1. Copper sulfate, 2. Barium chloride, 3. Lead nitrate, 4. Calcium chloride. Set Y contains 1. Sodium carbonate, 2. Sodium sulfate, 3. Sodium chloride. Now we will follow the steps one by one. Prepare separately a 5% solution of substances listed in X and Y in water. We take calcium chloride and sodium sulfate and make a solution of it. You will see the salts are being replaced by solutions on the screen containing colorless solutions. Take a little amount of solution of sodium sulfate in a conical flask and some solution of calcium chloride in an ignition tube. We hang the ignition tube in the flask carefully and see that the solutions do not get mixed. Put a cork on the flask. Now we have an ignition tube containing solution of calcium chloride dipped in a conical flask containing solution of sodium sulfate. Weigh the flask with its contents carefully. Now tilt and swirl the flask so that the solutions X and Y get mixed. Weigh again. Do you know what happens in the reaction flask? Do you think that a chemical reaction has taken place? Why should we put a cork on the mouth of the flask? does the mass of the flask and its contents change? Law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Lavoisier, along with other scientists, Proust, noted that many compounds were composed of two or more elements, and each such compound had the same elements in the same proportions, irrespective of where the compound came from or who prepared it. In a compound such as water, the ratio of the mass of hydrogen to the mass of oxygen is always 1:8, whatever may be the source of water. Thus, if 9 grams of water is decomposed, 1 gram of hydrogen and 8 grams of oxygen are always obtained. Similarly, in ammonia, nitrogen and hydrogen are always present in the ratio 14:3 by mass, whatever the method or the source from which may be obtained. This led to the law of constant proportions, which is also known as the law of definite proportions. This law was stated by Proust as, in a chemical substance, the elements are always present in definite proportions by mass. The animation here illustrates the concept of law of constant composition by taking different sources of the same substances, using the example of iron sulfide and copper oxide. 10 grams of iron and 4 grams of sulfur react to produce 11 grams of iron sulfide. The unreacted iron is separated using a magnet and was found to weigh 3 grams. Whatever be the source of iron and sulfur, they always combine in a ratio of 7:4 to form iron sulfide. In the second case, powdered copper and copper nitrate are taken into different crucibles and heated with the help of a Bunsen burner. In case of copper, we find that 2Cu plus O2 equals 2CuO. That is, copper combines with oxygen to form copper oxide. In case of copper nitrate, we find that 2CuNO3 2 equals 2CuO plus 4NO2 plus O2. Amount of copper oxide formed from copper turnings weighs 10 grams and from copper nitrate weighs 20 grams. When H2 is passed over copper oxide obtained from different sources, we find that CuO is reduced to copper and H2O. CuO plus H2, Cu plus H2O. When the amount of copper is obtained and weighed, we find that in first case it is 8 grams and in the second case it is 16 grams. This can be shown in the form of a table. From copper turnings, CuO, Cu, O2, 10 grams, 8 grams, 2 grams. Ratio Cu:O, 4:1. From copper nitrate, CuO, Cu, O2, 20 grams, 16 grams, 4 grams. Ratio of Cu:O, 4:1. We come to the conclusion that copper to oxygen in copper oxide is always 4:1, whether it is formed from copper turnings or from copper nitrate. Let us now discuss another compound, calcium oxide, CaO, which can be prepared by the following 3 independent methods. A. By heating calcium carbonate strongly, calcium oxide and carbon dioxide are formed. CaCO3 gives CaO plus CO2. B. By heating calcium hydroxide strongly, calcium oxide and H2O is formed. CaOH2 gives CaO plus H2O. C. By heating calcium nitrate strongly, 2CaNO3 gives 2CaO plus 4NO2 plus O2. The analysis of calcium oxide thus prepared by different sources shows that it contains the elements calcium and oxygen only, and the ratio by mass of the calcium to oxygen is always fixed, that is 5:2. This example illustrates the law of definite proportions. Let me now ask you a question. Name the law of chemical combination which deals with the composition of a compound. The answer is law of constant proportions. Let us now try to solve a problem. 3.18 grams of copper on heating in air gave 3.98 grams of black CuO. 1.06 grams of CuO on reduction with hydrogen gave 0.847 grams of copper. Show that these figures are in accordance with the law of definite proportions. Let us try to solve this problem now. In the first experiment, the percentage of copper in its oxide equals to the percentage of oxygen in copper oxide is equal to. In the second experiment, the percentage of copper in its oxide is equal to the percentage of oxygen in the oxide is equal to 100 minus 79.91 is equal to 20.09%. Since the percentage of copper and oxygen in both the oxides is same, the law of definite proportions is verified. Let us now try to solve a problem. The problem is, when 3.0 grams of carbon is burned in 8 grams of oxygen, 11 grams of carbon dioxide are produced. What mass of carbon dioxide will be formed when 3 grams of carbon is burned in 50 grams of oxygen? Which law of chemical combination will govern your answer? Let us now try to find the solution of this problem. Mass of carbon is equal to 3 grams. Mass of oxygen is equal to 8 grams. Mass of carbon dioxide is equal to 11 grams. The given data shows that in this reaction, both carbon and oxygen react completely to give 11 grams of carbon dioxide. In the second experiment, oxygen is present in excess. For complete combustion, 3 grams of carbon would need only 8 grams of oxygen to produce 11 grams of carbon dioxide. The excess of oxygen, 50 grams minus 8 grams, is equal to 42 grams, will remain in the mixture. Mass of carbon dioxide produced in the second experiment is equal to 11 grams. The answer is based on the law of constant proportions, or we can call it the law of definite proportions. Let us now try to solve one more example. Have a look at the data provided on the screen. We have to show that the data given below is in agreement with the law of constant proportions. 3 experiments are conducted in which the content of iron and iron oxide present is tabulated in the chart. Let us now try to find out the solution. From the given data, one can write the mass of oxygen per gram in case of experiment 1 is 1.22. mass of oxygen in case of experiment 2 is 1.31 and mass of oxygen in the third case is 1.93. Now let us calculate the ratio of mass of oxygen. Thus, the ratios of the masses of iron and oxygen in each experiment is constant at 1:0.43. So the given data is in agreement with the law of constant proportions. Law of multiple proportions. Stated by John Dalton, 1803, when two elements combine with each other to form two or more than two compounds, the masses of one of the element which combine with the fixed mass of the other bears a simple whole number ratio. Examples: carbon monoxide, CO, 12 parts by mass of carbon combines with 16 parts by mass of oxygen. Carbon dioxide, CO2, 12 parts by mass of carbon combines with 32 parts by mass of oxygen. Ratio of the masses of oxygen that combines with the fixed mass of carbon, 12 parts, 16:32 or 1:2. For example, hydrogen and oxygen are known to form two compounds. The hydrogen content in one is 5.93%, while in the other it is 11.2%. Let us show that this data illustrates the law of multiple proportions. Let us now find a solution to this problem. In the first compound, hydrogen is equal to 5.93%. Oxygen is equal to 100 minus 5.93 is equal to 94.07%. In the second compound, hydrogen is equal to 11.2%. Oxygen is equal to 100 minus 11.2 is equal to 88.88%. In the first compound, the numbers of parts of oxygen that combine with one part by mass of hydrogen. In the second compound, the number of parts by mass of oxygen that combine with one part by mass of hydrogen. Ratio of the masses of oxygen that combines with fixed mass of hydrogen, 15.86 is to 7.9 or 2:1. The ratio illustrates the law of multiple proportion. Here in this picture, we see an illustration of Dalton's law of multiple proportions. Atoms of nitrogen and oxygen can combine in specific proportions to make either NO or NO2. NO2 contains exactly twice as many atoms of oxygen per atom of nitrogen as NO does. 10 grams of CaCO3 on heating gave 4.4 grams of CO2 and 5.6 grams of CaO. Show that these observations are in agreement with law of conservation of mass. Answer is, the reaction takes place according to the following equation. Mass of the reactant CaCO3 is equal to 10 grams. Mass of products CaO plus CO2 is equal to 4.4 plus 5.6 grams is equal to 10 grams. Since mass of reactants is equal to mass of products, therefore observations are in accordance with law of conservation of mass.